Hello students, this is Mr. Yao. In this lesson, we are going to talk about 2.5a, where we will learn how to multiply radicals. It's a kind of similar process to the previous lesson, but of course with the multiplication as the extra step. So let's have a look. There are mainly two different methods. First method is you can multiply first and then reduce. And when you multiply, well, you have to make sure they're both the same kind of radical. In this case, both of the radical, it's a square root of 20 and a square root of 15. They both have the index as a 2. And that's the time that you can actually multiply them together. So it's going to give you a negative 4 square root of 300. And then we can take apart the 300. 250, 275, 3, 25, 5, and 5. So it is basically negative 4. Under the radical, we have a pair of 2, so 2 squared. We have a 3, and then we have a pair of 5. Then we can start taking things out to simplify. So you see from now on, it's the same as last lesson. So negative 4, and then you take out a 2 because we have a pair of 2, one pair of 2, so you can only take out 1. And the 3 is left inside. You have a pair of 5, so take out 1 pair, which is 1, 5. And then we multiply everything together. Negative 4 times 2 times 5 is a negative 40, square root of 3. That is method 1. Method 2 is you reduce first and then multiply, which means, so you see in method 1, we're going to get some big numbers because we're multiplying them together. And then sometimes that means your tree is going to be pretty big, or it's kind of harder to make the factor tree, which is why we can actually deal with them separately with a smaller number. So for 20, you have a 2 and a 10, and then it's a 2 and a 5. So it's a negative 4 square root of 2 squared times 5. We still have the square root of, that's a 3 and a 5, so it's just a 15. Stay there. And then you can see for the first part, you can take out a 2 because you have a pair of 2, so it's negative 4 times 2, and you're left with a square root of 5 and a square root of 15. And so after we reduce each of them, we can now multiply. It's going to give you a negative 8 square root of 75. But issue is, well, 75 can also be simplified more. So we need to keep doing a 3, a 25, a 5, and another 5. So that is going to be negative 8 square root of 5 squared times a 3. So you can take out the pair, which is the 5, and that's going to give you negative 40 square root of 3 as well. So for the first method, you may end up with a big number that you need to do a factory for, which may take a little bit longer. And the second method, sure, you have the small number to begin with, but after you simplify them, you might need to simplify again, like this one with the square root of 75. So that's kind of the ups and downs for both of the methods, which actually leads to potentially a third method. So method 3. What if you actually combine them? You can have the bigger number, well, you can somewhat have the broken down with little numbers, but you also don't want to get the bigger number. So let's see again. Negative 4 square root of 20 times square root of 15. Well, we can break it down. 2, 10, 2, 5. And this is a 3 and a 5. Well, now you can see, because everything is just being multiplied, that also means these factors are also being multiplied. So you can choose to break down the smaller numbers and then just put all of the factors together. So that will give you a negative 4. You're just counting all the factors together. A pair of 2, a 5, and a 3, and a 5. So it's a pair of 5 and a 3. You see, it's the same as what we had in the method 1. But we didn't actually have to get to the 300. We chose to just break down the smaller numbers, and then we can continue to simplify. So that potentially is a method 3. There you go. Now let's get to the examples. Example 1, you can choose to do either way. I'm going to show the method 3. 2, 3, 3, 5. So when you look at them together, it's a negative. Then under the root, we have a 2. We have a pair of 3, one from here, and the 5. Then, of course, because 3 is a pair, you can actually take a pair out, which leaves just a 3 in the front. Don't forget the negative sign. Inside, you have a 2 times 5. So the whole thing simplifies to be negative 3 square root of 10. That is example 1. Example 2, square root of 3. Well, because we have parentheses, we're distributing. So you're actually doing square root of 3 times square root of 6 plus square root of 3 times square root of 2. So you're basically doing 2 questions, like 2 example 1s. So the first one broke down 2 and the 3. So you actually have a 3 squared times a 2 And the second one, there's nothing you can do. It's just square root of 3 and the 2. I mean, you don't have a pair, so you have to keep them together. But for the first one, because we have a pair of 3, you can take it out. So it's going to be a 3 square root of 2 plus square root of 6. Now, some of you might be like, well, would that give you like a 3 square root of 8? But you can't, because these two are separate things. This is almost like you have a 3x plus y. Even though they both are square root, the numbers inside are different, so you can't actually combine them. So that is example 2. Moving on, example 3. All multiplication, but again, you can only multiply if they have the same radical symbol, they have the same index. So this is a square root, this is a square root, so you can actually combine these two. So let's break down the numbers apart. So it's a 2, a 10, a 2, and a 5. A 2, a 16, a 2, an 8, 2, a 4, a 2, a 2. So we can look at all the square roots together. 1, 2, 3, 4, 5, 6, 7. 7, 2, so it's 2 to the 7th power times a 5. But then don't forget, we still have this cube root of 8. Cube root of 8. Now let's simplify. The first part, 2 to the 7th power. 7 has 3 pairs with an extra. So it's going to be 2 to the 3rd power that you can take out, leaving a 2 and a 5 inside. And then we still have the cube root of 8 is 2 to the 3rd power. Now let's keep simplifying. So this is a 2 cubed, which is 8. Left inside you have a 10. Multiply. That's a cube root of a 2 to the 3rd power. So the cube root of 8 is cancel. Or you can think, how many triples can you take out from a 3? Well, you can take out 1. Then you're left with a 1 inside, which is nothing. It's just a 2. The whole thing simplifies to be 16 square root of 10. Now, what if this question, instead of giving you a cube root of 8, I actually give you a cube root of 16. That would be cube root of 2 to the 4th power, which would simplify to be 2 cube root of a 2. In that case, your answer would be 8 square root of 10 multiplied with the 2 cube root of 2. The whole thing will become 16 square root of 10. You still have to leave the cube root of 2 because they're not the same index. You can't multiply them. Which, if you think more, well, that's a 10 to the 1/2 power. That's a 2 to the 1/3 power. They don't even have the same base. And also, they don't have the same exponent, so you can't do anything about that. That is example 3. Example 4. Now we're expanding. We have parentheses times parentheses. But you have to kind of think about the square root like your x. If I give you this question as x plus 1, negative 2x minus 1, you might be pretty clear on what to do. We're going to make a box. So same thing here. Let's make a box. We have a square root of 5 and a 1 and a positive 1. We have a negative 2 square root of 5 and a negative 1. Let's multiply. If you are having trouble multiplying them, you're like, just by looking at them, I don't know what they are. Well, then write out. So for the first box, you're going to have negative 2 square root of 5 times square root of 5, which is negative 2 square root of 25, which is, or you can think it as negative 2 square root of 5 squared. Take out a pair, so it's negative 2 times 5, which is negative 10. 1 times negative 2 square root of 5 is just negative 2 square root of 5. Negative 1 times square root of 5 is a negative square root of 5. Lastly, negative 1 times 1 is a negative 1. Let's write them out. Negative 10 minus 2 square root of 5 minus square root of 5 minus 1. Combine like terms, numbers together. Negative 10 and negative 1 is negative 11. Negative 2 square root of 5 and negative square root of 5 is a negative 3 square root of 5. That is example 4. Moving on, example 5. I've been repeating this for some time now. Whenever you see a square, write it twice. Square root of 7 plus square root of 5. So now you see it's like the previous example. We're going to create a box. Square root of 7, positive square root of 5, square root of 7, positive square root of 5. Let's multiply. Square root of 7 times square root of 7. Square root of 7 times square root of 7 is square root of 7 squared. Then you can start taking things out with leaving a 1 under the radical, which is just a 1. The whole thing is a 7. Square root of 7 times the square root of 5 is a square root of 35. Square root of 7 times square root of 5 is a square root of 35 again. Square root of 5 times the square root of 5 is a positive 5. Let's write them out. 7 plus square root of 35 plus square root of 35 plus 5. these two numbers together, 12. You have 2 square root of 35, so it's going to be 2 square root of 35. That is example 5. Example 6 is getting a bit more complicated. There are a lot of things happening. But one thing, these are both the fifth root. So the first thing you got to be clear is you need to deal with things separately. Like, as in things outside the radical, put them together, and things inside the radical, put them together. So first step, you have a 6x, and you have a 4xy. I'm just putting the things that are outside the radicals together. As for the radicals, they're both fifth root, so I can just put them all under. 16, x to the 7th power, y to the 9th, multiply with 18, x to the 4th, y to the 4th. But first, let's break down the numbers. 16 is, so I'm going to copy down that. 16 is 2 to the 4th power, x to the 7th, y to the 9th. Keep going. 18 is 2 times 3 squared, and x to the 4th, y to the 4th. Still leaving I can kind of already combine them. 24 x squared y. Multiply the numbers together, you have x and an x, which is x squared, y is still there. Now I'm going to copy it down again, 24 x squared y. Then I'm going to start putting everything inside together. It's a fifth root. So you have a 2 to the 4th power and a 2, that becomes a 2 to the 5th power. 3 squared, that is just 3 squared. And then we have x to the 7th power and x to the 4th power. Together, that is x to the 11th power. And then we have y to the 9th power, y to the 4th power. Together, that is y to the 13th power. Now we have taken care of everything inside, we can start taking them out of the radical. It's a 5 as the index, so you are taking things out in groups of 5. So let me copy down the front. And let me also still write down the fifth root of something. Let's start taking things out. 2 to the 5th power, you have one group of 5 of 2's. Only one group. So you can take out a 2, leaving no 2's inside, so that is gone. Then for 3 squared, there's no groups of 5, so that stays in. For x to the 11th power, there are 2 groups of 5, so take out an x squared, leaving just an x inside. Y to the 13th power, there are 2 groups of y, so it's y squared out, leaving a y inside. Lastly, we simplify. 24 and 2 together, that is 48. X squared and x squared together, that's to the 4th power. Y and y squared together, y to the 3rd power. Then you still have the fifth root of 3 squared is a 9, x and y. Oh, I forgot. Y after you take out, you have actually y cubed. So it's going to be y cubed left inside. That is example 6, and that is everything for multiplying radicals. Thank you.